basic theorems. So as sine x approaches 0, we have 0. As cos x approaches 0, it goes to 1. And then when we put the sine x over x into our calculator, we get a non-permissible value or open dot at 0, but from the left and the right, it approaches 1. So if I can ever get an equation into sine x over x, I can say that at it approaches 0, I can say 1, correct? Now put into your calculator, what if I do sine 5x over 5x? Put this one in. So type that into your y equals. It's very similar, doesn't it? We still have a non-permissible value at 0. We agree? And this here is just horizontally stretching it by a factor of 1/5. We agree? So if I horizontally stretch it, does it make the symmetry of this different? No. It's still going to approach 1. So also the limit as x approaches 0, if I get 5x over 5x, my answer is still 1. Okay? Could be 10x over 10x, pi x over pi x. It doesn't really matter as long as they're the same values. See that? So technically, if I wanted to, I could say the limit as x approaches 0 of sine bx all over bx will equal what? Where b can we'll say is greater than 0. Right? So, people will say to me, on this one. Yeah. People will say to me, okay, that's great. You said sine 3 theta. I have to hold on papers. Sine 3 theta over theta. As I approach 0, cool. People will tell me it's 3, or they don't even know what it is. Is this in the format of that? No. What do I need in order for it to be in the format of that? I have sine 3 theta over, what do I need it to be over? 3 theta, right? So I need this to be a 3 theta. True? Can I just randomly multiply a bottom by 3? I have to also do what? Multiply the top by 3. True? Remember limit laws, you can multiply, you can separate them by multiplication. So we could go the limit as theta approaches 0 of technically 3 times sine 3 theta over 3 theta. And what is sine 3 theta over 3 theta? 1, right? And what's the limit as I approach 3? It's just a 3, right? So if you think about it, that's the line y equals 3. Yes? So I'll split these up so it makes a little more sense. So I can go the limit as theta goes to 0 of 3 times the limit as theta goes to 0 of sine 3 theta over 3 theta. So it's what the graph approaches from the left and the right. We agree? We know in this format, the sine 3 theta over 3 theta, it's going to approach 1, correct? So I'm going to put a 1 there. We talked about that. This one is the line y equals 3, technically, yes? So if I put y equals 3 in my calculator, it would go like this. We agree? Y equals 3. So from the left and the right, what is it approaching? 3. So that's why whenever you get just a numerical value, it is that value. Because no matter where, if I'm approaching 0, 1, 2, 3, 4, 5, 6, 7, infinity, it's always going to approach 3 because it's a horizontal line at 3, right? No matter where I approach, it'll be 3. So that's why constant functions just stay the same. Does that make sense? So we want to know why we do stuff. We don't want to just memorize that when it's a constant, I just rewrite it. Do you understand why you rewrite the 3? Because that's a horizontal function, and no matter where you approach the left or right of any value, it'll be 3. Make sense? All right. So our answer is 3. So that's if you're given approaching 0, correct? You have to have sine 3 theta over 3 theta. Okay. What is our problem with B? If we have sine 5 theta, it has to be over 5 theta. And sine 2 theta, it has to be over what? 2 theta. True statement? Okay. So I want you to think of, I'm going to do this. The limit as theta goes to 0 of sine 5 theta over something divided by sine 2 theta over something. Okay? Question here. All right. So, most people know that I need to get a 5 theta down here, correct? And what I do, I have to the bottom, I have to do the top. But then they're wondering if you have to do it to the bottom as well. Sometimes it's easier to see it if you write it as sine 5 theta, which I'm not going to, but I just want you to see why I'm doing what I'm doing, divided by sine 2 theta over something, correct? So if I multiply this by 5 theta, do I have to do it to this side as well? If it's sideways, you don't ask that question. If they're side by side, you're like, no, I need to just do it to here, and then I have 1. That 5 theta divided by 5 theta is 1, right? And you know you don't need it to do it to that side, if you write them sideways. If you write them stacked, people go 5 theta here, and then they're like, oh, do I need to put the 5 theta down here as well? That question always happens. But if you write them out sideways, no one ever asks that question. Like, okay, I put it on this one. Cool. What do I need to put on this one? 2 theta down here, so I have to multiply the front by 2 theta as well, because 2 theta divided by 2 theta is 1. So I can do a 2 theta down here, and a 2 theta here. So technically, on the top, I have the limit as theta goes to 0 of 5 theta. What does this turn into? A 1 over 2 theta. What does that turn into? 1. Five theta and 2 theta are monomials, correct? There's no plus signs, there's no minus signs, there's nothing connecting the terms. So can I cancel the thetas off? It's like having x's. Can I cancel them off? Yep. The 1s are gone, because it's just a 1. So I'm left with the limit as theta approaches 0. Wow, I put like another theta. Theta approaches 0 of 5 over 2. So 5 over 2 is 2.5, same thing, correct? Same thing. So if I drew that line, it would look like that. Yes? As I'm approaching 5 over 2 from the left of 0 and the right of 0, what does it equal? Yeah, 2.5, 5 over 2, right? Constant functions just end up being that. Do we agree? When you're done this, or you're done?